3 double angle formulas. I'm going to show you how to kind of derive some of these. So I'm not going to read through this a whole lot, but the idea is I'm going to take sine of 2 theta and think of it in terms of angle addition, which would mean that 2 theta was theta plus theta. Okay, so I'm going through and I'm pulling from that sheet the sine of theta times the cosine of theta minus the cosine of theta times the sine of theta, rather plus. Now, just because the sine and cosine are flipped around, they're still comprised of the factors of those two. So it really becomes 2 sine of theta cosine of theta. And there's a double angle formula for sine. Going to do the same thing for cosine. I'm going to make cosine into angle addition, so theta plus theta. This is where my subtraction takes in. I'm going to go with the cosine of theta times the cosine of theta, which if I multiply those two together, it gives me cosine squared of theta, minus the sine of theta times the sine of theta. Same thing, multiply them together, and it gives me sine squared of theta. And I end up subtracting them, and that is one of my, wait a second, it says 3 forms of cosine of 2 theta. And it is. Now, I'm not going to show how to come up with both of those, but if I also use the Pythagorean identity of sine squared theta plus cosine squared theta is equal to 1, do a little bit of subtraction, a little bit of substitution, I end up with another couple of versions. So another version would be I could have 2 cosine squared of theta minus 1, and another one where it's 1 minus 2 sine squared of theta. Okay, tangent of 2 theta, I'm going to do the same thing. I'm going to write that as angle addition. Oh, color coding gone wild. Tangent of theta plus theta. So it was tangent of theta plus, oops, come back now, plus tangent of theta. I'm really looking at my angle addition, and then 1 minus the tangent of theta times tangent of theta. So on the two top ones, I can add them to get 2 tangent of theta minus 1 times tangent squared of theta. Okay. Again, these are all on the double angle sheets. There's nothing that you need to worry about memorizing. Just kind of showing you how they come around. It's basically just angle addition of the same angle. So how do I calculate a formula? Well, here I got cosine squared minus cosine squared. So if I look at my sheet, that looks like cosine squared of this angle minus the sine squared of this angle is the same formula as cosine of twice that angle. So if my angle is 15 degrees, that means I'm taking the cosine of 2 times 15 degrees, or the cosine of 30, and I'll go off my triangle, 2 square root of 3 and 1. Cosine is going to be the square root of 3 over 2. Okay, double sine of the angle times double sine of the angle, so 2 sine theta times cosine of theta, that is sine 2 theta. My theta here was 22.5, so I'm going to do the sine of 2 times 22.5, which is going to give me the sine of 45, which is the square root of 2 over 2. Right, so just using the double angle formulas, kind of modeling off that sheet. Here I've got sine of A is negative 4/3, so that means it's in the 3rd quadrant. So here is angle A in the 3rd quadrant. That means here the y value, negative 4. Here's my 5, and just for good measure, I'm going to put in negative 3 right there. Again, I use Pythagorean triple. You could use Pythagorean triple if you, or theorem if you want. And I'm going to do the sine of 2a, or sorry, tangent of 2a. Looking at that sheet, 2 tangents of a over 1 minus the tangent squared of a. Well, tangent would be opposite over adjacent, so tangent of this a is going to be 4/3. So 2 times 4/3, my 1 minus 4/3. thirds squared. So here I've got 8 thirds on my numerator. And on the bottom, I got 1 minus 16 ninths. So if I get a common denominator of 9 over 9, that is going to be over negative 7 ninths. Do a little multiplying by the reciprocal. And I am going to reduce that by 3. So I got 24, negative 24 over 7 for that tangent. Whoo-wee. Okay. Let's see. Find tangent of 2a. Okay. All right. Tangent of theta is 4 over 3, where theta is now in the third quadrant. So here's my angle quadrant 3 again. Now, since I'm in quadrant 3, I'm going to go over negative 3, negative 4. I guess I'm skipping this, but this is y over x. So here is my y value, here's my x value. I'll find the radius, which is going to be 5. Again, Pythagorean triple. Find the cosine of 2a. So I'm going to go cosine of 2a, which is, again, it doesn't matter which one I pull, but I'll go with this one of cosine squared of a minus sine squared of a. Cosine is going to be x over r, so I'm going to take negative 3/5 and square it, minus the sine squared, so negative 4 over 5. I'll square that. So that's 9 over 25 minus 16 over 25. Got my common denominator of 25, negative 7 over 25. And that is how you use the double angle formulas.